Good day. My name is Zangaphee Chimombo. I'm a PhD student at Chancellor, University of Malawi in the African Languages and Linguistics Department. And my presentation today is preliminary data findings, presentation of preliminary data for my PhD study, which is Bantu machine translation proof of concept using ciNyanja and ciYawo. So Africa has been known as the mobile continent, and this is because the internet reaches most of us via the mobile phone. And when barriers to such access is discussed, usually it's broken down into cost. Cost to the operators of rolling out infrastructure, cost to the end user for handsets, data tariffs, but rarely is the content actually mentioned. Most of this content is in non-African languages, in non-local languages. So where my study can fit in and perhaps assist is in making such content more accessible to African consumers. So this is where MT can fit in. So the aim of my study is to demonstrate that Bantu MT is feasible, it's possible, and then outline the requirements. So both in terms of the corpora and other language data, and then the steps, what's actually required, what are the steps, so that other researchers in other languages, in the thousands of Bantu languages or hundreds of Bantu languages and other African languages and other low resource languages may follow more easily in these steps. And then overall, to establish a translation quality metric that can be used as a basis of comparison in the future. This will not be part of this presentation, but it is an objective in the overall study. So rule-based machine translation. There are several approaches, of which rule-based MT is just one. The others are very data intensive, and RBMT is what is known as knowledge-based. So a researcher would need to know both languages, or a team of researchers would need to know both languages, and therefore compile the parallel word lists, compile the translation rules, and build up the language pair package. And we chose Apertium, and I think there's a lot of information about that on the internet. The alternative approaches, the data intensive ones, are statistical, and now, more recently, neural network based and MT. So more about that in a couple of slides. Why is this significant? Because buzzwords such as AI, CAL, so artificial intelligence, computer-aided language learning, these will remain out of reach of the African masses unless we narrow that digital language gap. So we're talking of, if we're talking of Malawi, where the majority do not understand English, then all these benefits, all these breakthroughs are out of reach. And just to give an idea, a study last year looking at the home assistants, Amazon, Apple, Google, their home and smartphone assistants, 8 languages supported by Alexa, of which Japanese and Hindi were the only non-European ones. Siri from Apple supports 21, Google Assistant supports 13, none of them are African. So again, works such as this study can contribute to putting African languages at that cutting edge of technology. My uncle in the village who speaks ciYawo would want Alexa in his home, I'm sure. Just a look at the alternative approaches that have been mentioned. SMT, statistical machine translation. So some work has been done using what's known as Moses open source toolkit, and no surprise there, Swahili has been used. And what came out of this study is that corpora of around 2 million words are required. It was also observed that quality is proportional to the log of the amount of training data, which makes it expensive to continue to improve system quality just by adding more data. So as the training data increases, the quality sort of levels off. And then what must be observed is that the largest parallel text currently available in both languages of this study, ciNyanja and ciYawo, are the Bible and the Quran, and their combined total is less than 1 million words, far short of this 2 million minimum requirement for SMT that's been mentioned. Neural machine translation has been used for African languages, especially South African. And here it's been demonstrated that NMT begins to outperform SMT around 15 million words. This was done not with South African languages, but with English, Spanish. So it's just put here as a yardstick. So if SMT, which requires about 2 million words, is out of reach for our language pair, then NMT is currently or extremely out of reach. So no hope in trying that just yet, maybe in a few years' time. And then one of the beauties of actually using RBMT to start off with for low resource languages is that you can forklift whatever language pair or language into such a state where it is now ready for data intensive approaches. So as a result of this study, hopefully the 1 million parallel text, the 1 million word parallel text will be raised, maybe even until such a position where NMT is feasible. So what are the steps in actually building an RBMT package? I started off with a Swadesh list. It's a 207 word tool. It was originally developed decades ago for lexico-statistical purposes in comparative linguistics. And it's got a lot of languages out there. You Google Swadesh list, you Google Bantu Swadesh list, you get hundreds of data sets. They may not all be complete, they may not all be, they may need data cleansing, they may not all be accurate, but they're out there. It's somewhere to start. This list, the Swadesh list, is obviously 200 words is not a lot, so it's obviously inadequate, but it's a starting place. It's also been criticized for being Eurocentric, no surprises there. There is a specifically African word list of 1,700 words, but that came out in 2006 and is not yet widely adopted. Just to repeat, the Bible and the Quran have close to 1 million words in total, and they are widely translated. So not in this preliminary presentation, but as part of this study, they will be used for evaluation. And then the Universal Declaration of Human Rights, 1948, and the Sustainable Development Goals, both sort of UN documents. These have also been widely translated into many languages, including both ciNyanja and ciYawo. Now, they're just a few thousand words each, but in terms of tuning and evaluation, they'll be useful corpora. Now, Bantu languages have a rich morphology. I think those who are aware of the noun classes. There's a couple of dozen noun classes. They are pro-drop in that a verb can stand alone in a sentence. And then we have hundreds of pronouns and morphemes. So that's just a little bit of linguistics. The actual machine translation process that Apertium uses can be presented in such a diagram where the rising edge of analysis, we have the input source text, which it's deformatted to remove various tagging, for example, HTML tags, and then it's analyzed morphologically, and then it's post-tagged, part of speech tagged, and then the lexical and structural transfer takes place using translation rules, and then the generation of the output target text begins with the morphological generation, the post generator, and then the reformatter. So putting it back into, let's say, Microsoft Word, HTML, LaTeX, and that is the process in diagrammatical form for the MT. The major outcomes so far, by limiting the scope to 4 grammatical categories, so noun, verb, adjective, pronoun, and a limited lexicon, just the 207 Swadesh list, and just a simple tense. So nothing of the rich tense aspect and mood that languages have. And just to demonstrate that the process is complete, we scored a WER of 20.83 in one direction and then 29.17 in the reverse direction. These are not yet benchmarks, but eventually when we do come up with benchmarks, the same process will be used. In conclusion, the study has shown that it is possible to extend an RBMT, a rule-based machine translation package, to a Bantu language pair, ciNyanja and ciYawo. This is the Apertium, using the Apertium package. We have identified some word list corpora that can be used and are widely available. And then we've documented the process, the iterative process of preparing the data, evaluating, testing it, going back to the data and tuning it, and then the final evaluation as well. So this has been presented. And then by the end of the study, my PhD study, we will have a reliable benchmark or reliable benchmark scores in both directions that can form a basis for future improvement. So in future, when this language pair is able or has enough corpora or large enough corpora for SMT and NMT, those scores can be used to compare with RBMT. Thank you.